G'day team, welcome back to another video. So today we are continuing on with our polynomial work. We just finished looking at cubic functions and their graphs. So now we are going to move on to quartic functions, so that next step up. So this is looking at chapter 4F in the Hazy 11 Methods textbook. So a quartic function has the form y equals ax to the power 4 plus bx cubed plus cx squared plus dx plus e, where those a, b, c, d and e coefficients are constants. And remember, our a cannot equal 0, otherwise we just have a cubic function. So the simplest quartic function is y equals x to the power 4, and it looks like this. So whenever you input an x, that x is multiplied by itself 4 times. So with 1, obviously it's 1. If you have x equals 2, 2 to the power 4 is 16, okay? And just note that the graph is flat at 0, 0. I know my diagram doesn't look like it too well, but it is actually horizontal at that point. So, like quadratics and cubics, quartics can be written in expanded form or factorized form. So for example, here I've got y equals x plus 1 times by x take 2 times by x plus 3 times by x take 4. So 4 unique linear factors. And this actually expands out to be x to the power 4, take 2x cubed, take 15x squared, take 10x plus 24. So you can write them in both. In this video, we're not going to look at factorizing quartics. We're just going to be looking at the properties we can pull from the factorized form and graph those, all right? So the factorized form tells us most of the information about the graph that we need. So some key properties of quartic functions or graphs. So if a is greater than 0, so if the a out the front of our function is greater than 0, so positive, our quartic opens upwards and it looks like a W, all right? So we'll have 3 turning points and our 2 ends, our 2 arrows, will be shooting upwards. If a is less than 0, our quartic opens downwards. So we've still got those 3 turning points, but our 2 end points will shoot off downwards, so we get an M looking shape. So just like I did with cubics, we're just going to go through a few different forms of quartic polynomials and what their graphs look like. So if we do in fact have 4 unique linear factors like this, then the solutions to those 4 linear factors are indeed our x-intercepts, okay? So all of these examples will be for a greater than 0, just for continuity, all right? So Q, R, S, and T are our x-intercepts. The next type we can have, so the next form, are 2 linear factors multiplied by a repeated or a squared factor, okay? Just like in cubics, if we have a squared factor, then our graph or our function will actually touch the x-axis at that point. So we still get it cutting through Q and R, then we get it touching at S. Okay, so if you see our graph touching or if you see a squared factor, we know that those 2 are together. The third form, as you probably guessed, is when we have a factor to the power of 3. So if you do remember in our cubic video, when we do have a factor cubed, that means it's horizontal at that point, okay? So x take q still gives us a cutting through the x-axis, but x take r to the power 3 gives us that the function's actually horizontal at that point r. And then finally, our fourth format or form is when our linear factor is to the power of 4, okay? We just get that our function is actually horizontal at that point q, okay? So there are 4. The other 2 things you have to keep in mind, okay? So if a quartic with a greater than 0 has 1 real quadratic factor with its discriminant less than 0, we could have a graph that looks like this, okay? So we've got to look at it as something like this. So P of x equals, if we have, say, x plus 2, x take 1, and then x squared take 4x plus 7, okay? So that is a quadratic that has a discriminant less than 0. So we could kind of break down our graph with these here. So these two linear factors here, all right, doesn't look like it on my graph, but just pretend they are these two intersecting points, where our quadratic with a discriminant less than 0 is the rest of it that doesn't actually touch our x-axis. Remember, when a quadratic has a discriminant less than 0, it does not touch the x-axis. So if we have a quartic with a greater than 0 and it has two real quadratic factors with discriminant less than 0, so it has two quadratics that are of this form, we could have something that looks like this, so the whole function does not touch the x-axis, okay? So with that, we're going to do an example. So we're going to sketch the graph f of x equals negative 2x times by x take 1 squared times by x plus 3. Now I like to rewrite this so we're sort of ascending in order. So we've got our a value at the front, then we've got our linear factors, our squared factors, and then if there are cubed factors or factors to the power of 4, we include them at the end. So what we do now, we sort of define, or we look at and label what our x-intercepts are doing. So with linear factors, okay, it cuts the x-axis, okay? So it cuts the x-axis at the solution to these linear factors. All right, so when x is 0 and x is negative 3, and then it touches the x-axis at 1. Because this is a squared factor, if we look back up in our little table, we can see that that squared factor, it touches. So that's how we classify. And then we look at our a value. So a is negative 2, which is less than 0. So we know that our function will open downwards. The last thing we need is our y-intercept. So y-intercept when x equals 0. So therefore our y-intercept is 0 in this case. So now that we have y-intercept, we've got our shape, and we've got our intersects, all right, we can sketch our graph. Please make sure that you have correct labeling for your axes, label your function, and then also clearly label the points that it runs through, okay? So because it opens downwards, we start down here, move up through negative 3, down through 0, and then it touches at 1 and shoots off downwards. Make sure with Quartics that your graphs are both either facing down on each end or facing up, depending on your a value, okay? Example 2, find the equation of the Quartic with the graph that looks like this. So what you need to do, you need to compare to, in the table above, what your shape looks like. So I can see that we have 4 unique linear factors. So we're going to find what linear factors those are. So negative 6 comes from the linear factor x plus 6, negative 4 comes from x plus 4, negative a half comes from 2x plus 1, and 2 comes from x take 2. So all we need to write now is y equals a times by all of our linear factors together, okay? So we're not quite done finding the equation. We need to find our a value. So we need to look for one more piece of information on our graph. And I can see that our graph actually intersects the y-axis at 12. So that means at x equals 0, y equals 12. So we substitute that in. So y equals 12 and all my x's have turned to zeros and disappeared. So now we've got a, so 12 equals a times by 6 times by 4 times by 1 times by negative 2. So 12 equals negative 48a. A equals negative a quarter. Now that we have a, we just substitute a back into here, and that is the equation of our graph. All right, hopefully those 2 examples are useful. Please have a crack through some of the questions, and we'll see you in the next video.